All right, problem 18 says the graph of f prime, the derivative of the function f, consists of two line segments, they're here and there, and a semicircle, as shown in the figure above. If f of 2 is 1, then what does f of negative 5 equal? So just to organize this in a way that where we've kind of done this stuff before, we want to know what f of negative 5 is, but we have f of 2. We also have all sorts of information about f prime. So let's think, what should you do to f prime to get f? Yep, antiderivative or integral. So if we were to take the integral of f prime of, does it matter if I put t or x? Probably not. If we were to do the antiderivative of f prime, we'd get f, right? And then let's use some strategic bounds. So let's use 2 and negative 5. I like it when it goes left to right, so I'm going to go negative 5 to 2 for x. Okay, now let's interpret what this means. So the antiderivative of f prime would be f, and we plug in the upper bound and lower bound and subtract the results. So this would equal f of 2 minus f of negative 5. You're going to notice this move is going to come in handy many places on your AP exam because it's the AP calculus test, so they want you to demonstrate knowledge of the fundamental theorem of calculus. All right, so now let's figure out how on earth are we going to figure this out, right? Well, this would basically be the area bounded between the graph of f prime and the x-axis on the interval from negative 5 to 2. So that would mean, so here's negative 5 to negative 2. Here's negative 2 to 0, and here's 0 to 2. So at this point, we're going to use our connection between area and integrals to get a value for this integral. So let's start by finding the area of this triangular region here just by doing 1/2 base times height. The base is 3 units, the height is 2, and so the area of that rectangle, or sorry, this triangle would be 3. This is a half circle. Its radius is 2. So its area would be 1/2 of a pi r squared, where your r is 2. So your area would be 1/2 pi, and then your r is 2, and you'll square it. Simplifying this mess, we end up with 2 pi. So these are areas. Area is always positive, but integrals aren't, right? So this integral is going to use your y-coordinates for heights, and it can't tell if you're using negative numbers for heights. So your integral from negative 5 to negative 2 would be equal 3. But then you'd also have whatever your integral would get for this part. Since it's underneath the x-axis, instead of getting 2 pi, your integral would have gotten negative 2 pi for that part. F of 2, my friends, is equal to 1. And we're trying to figure out f of negative 5. There you go. Now it's just a matter of solving the equation for f of negative 5, and up to you how you want to do it. So I don't know, I personally would add f of negative 5 to the other side and subtract this stuff over. So I'd end up with f of negative 5 is equal to 1 minus 3 would be negative 2, and then you would have subtracted that negative over. And so you'd end up with whatever's equivalent to negative 2 plus 2 pi, which looks like a here.